Hi, my name is Citlali, and today I want to explain to you what this picture with bees flying around in space is all about. To do that, I'm going to talk about three things. I'm going to talk about small satellites, I'm going to talk about swarms, and I'm going to talk about myself. So, I'm an aerospace engineer, and whenever I tell my friends that I'm an aerospace engineer, the first thing they ask me is, "Ooh, do you work at NASA?" When I tell my family that I'm an aerospace engineer, the story is a bit different, because they ask me, "So when are you going to the moon?" So what is it exactly that I do? Well, there's many things that aerospace engineers do, but what I personally focus on is designing satellites, designing space missions. This involves a lot of modeling, a lot of programming. You need to simulate the satellite, the conditions in space, how the satellite moves, how you can control it. Then you move on to manufacturing the satellite. So you put all of your components together. Then you test your satellite. You test it a lot in conditions that are very similar to the ones that you will have up in space. And we do this just to make sure that our components are actually going to work once we send it up there. Fun thing about this part is that you actually have to protect the satellite from contamination from yourself. And that's why you get to wear these very fun clothes. We do all of this so that in the end we can send the satellite to space, it works, and we get something back. And I do that for very small satellites, which I think is awesome. And so I tell my friends and family about this, and they say, "Yeah, right, sure." So why am I so excited about this? How small am I talking about? Let's see. The largest satellite in space is the International Space Station. It's about the size of a football field and weighs around the same as 3 fully grown blue whales. So I'm definitely not talking about this satellite when I say small. But how small? And for this part, I would like to do a small exercise with everyone. So if everyone can raise their hands with me. Amazing, thank you so much. Now we know the largest satellite in space, the International Space Station. That's about 450 tons. On the screen, you will see the numbers going lower and lower. And whenever you see a number and you think, "Oh, come on," there's no way that a satellite weighs that number. Lower your hand and we'll see what everyone in the room is thinking, okay? So we start with everyone with their hands up. Let's start by going down to 1 ton. Good start. 100 kilograms. Okay, some hands down over there. Someone thinks we can go lower than 100 kilograms, maybe down to 10 kilograms. More hands down, 1 kilogram. How about 10 grams? We still have very optimistic people in the audience. Wow, nice. Wait a minute. Are you still optimistic if I go down to 1 gram? Wow, nice, thank you. Very optimistic. Thank you very much. So now, I would like to show you with some real-life examples how low we can actually get. And I will start with Discover. Discover is a satellite that takes measurements of the sun and how it interacts with the atmosphere of Earth. And it's small enough that I would be able to fit it quite nicely inside a parking space without hitting the cars next to it. But it weighs the same as a grand piano. So it's still pretty big. So let's go even further down to something I can actually carry with my own hands. For example, S-Cube-2. This is a satellite built by students in the University of Tartu in Estonia, and it is so small that I would be able to fit it inside this shoebox. I can also carry it because it weighs the same as I did when I was 1 month old. But what if I told you that I can fit multiple satellites inside this shoebox? That would be cool, right? Well, let me show you because I actually can. This is Poquito. We built it at SNT in the University of Luxembourg, and yes, it's a satellite. Now, the cool thing about this satellite is that now everyone in this room can say that you have seen a real satellite with your own eyes. And I know many of you may be looking at it and thinking, "Wait a minute, that seems familiar. Where have I seen that before?" Let me help you. Because it's the same size as a Rubik's Cube. Another fun fact about this satellite, it weighs the same as 16 Oreos. So this is very small, right? But it's not the end of the story, because we have an even smaller satellite right there. I also brought it with me today. It's right here. Now, you see we place it on top of Poquito, and we do that so that once we send Poquito to space, we can also test the ChipSat at the same time, but it's an independent satellite. And in terms of size and weight, it's smaller than this slice of cheese. So now you know, next time that you're making a sandwich, you have a model of a satellite in your hands. I think by now I've convinced you that this is very cool, right? But now what? What can we actually do with them? Well, as an aerospace engineer, I would tell you, let me put one of them in space so I can test it. And you might think, okay, but it's tiny. It seems a bit useless to send one of them to space. And I have to say, yes, that's fair. Because for sure, given the size of the satellite, it is more limited in what it can do than a larger satellite. But what if we send many of them together? What if we use the concept of a bee swarm, like the one I showed you at the very beginning? They are strong because of their numbers, and they work together towards the same goal. In fact, we already have some examples of satellites that work together with the same goal. And I think some of you may have even seen some of these constellations of satellites with your own eyes. If anyone has looked up at the night sky and seen what looks like a line of stars or bright lights moving across the sky, then you have seen Starlink, which is SpaceX constellation that provides internet around the Earth. But even if you haven't seen Starlink, I can assure you that you have interacted with one of these constellations of satellites on your way here today. Well, maybe yesterday or the day before, because GPS is also a constellation of satellites. I have to admit, though, I got a bit sidetracked here, because both Starlink and GPS are actually quite big satellites. And here today, I want to discuss the shoebox, the Rubik's Cube, and the cheese satellites. So let's come back to them. What can we actually do with these sizes? To answer this question, I would like to come back down to earth for a moment and talk about something that I struggled with coming from Mexico to Luxembourg, and I think many of you in Luxembourg can relate to, and that is the struggle with weather. Every day I need to check the weather forecast to see if it's going to be rainy, sunny, cloudy, or if there will be a storm. Well, it turns out that there are also storms up in space. We have high-energy particles coming from outer space. There is solar activity. There's a lot going on out there, and all of that we call space weather. In fact, there's one type of space weather we can see with our own eyes from down here on Earth, and that is the aurora. Aurora happens when particles and energy from the sun interact with Earth's atmosphere and magnetic field. And sometimes we have very intense aurora. I remember last year we were able to see it from some parts of Luxembourg, and even some weeks ago they were able to see it from back home in Mexico. This very intense and visible aurora happens when there is a lot of activity going on the surface of the sun. And this is not all the time. So when one of these events happens, we could send a swarm of satellites to take measurements along the aurora to actually understand it better than we do today. We can also use them for communications, because every day people want more connectivity. We want to stream videos, to be on social media, to send messages, and so we need the satellites that provide that signal to be larger and larger, simply because we need larger and larger antennas. But there's going to be a point where we reach the limit of how big a satellite we can send to space simply because of how big our rockets are. When this happens, though, we could send multiple smaller antennas and put them together up in space to create an even larger antenna. But my favorite application of all is to observe Earth, because different satellites have different types of cameras. So they give us different views of Earth, and we can study many things. For example, we can track vegetation, so we can see how agriculture is doing. We can also see how animals are moving and migrating from place to place. We can forecast the weather. We can track deforestation, monitor wildfires. We can study climate change. And these are just some of many other examples. So these constellations of satellites are really helping us to understand better our world. And I hope by now I've given you a better idea of what this picture with bees flying around in space is all about. In the end, these swarms and constellations of satellites are really helping us, and they are one more tool that we can use to understand better our world, to have better connectivity, to understand phenomena like aurora. And so next time that you're at a dinner, maybe later today, you want to talk to someone, but maybe you don't really know how to start a conversation, maybe you want to talk about the weather, well, I have a suggestion. Why not start with, hey, do you know what bees, a Rubik's Cube, and a slice of cheese have in common? Thank you very much.